What's up, chemistry? Welcome back to the Dirt Bike Shed. We're going to do another mole lesson today because the mole is a very important part of chemistry. It's one of the biggest subjects in the entire course, and you need to have an understanding of it. The mole is going to be used in the next chapter as well when we do something called stoichiometry, period. But today I'm going to try something new. I'm going to work some problems with you, and I'm trying out a new computer program. So here we go. Let's do it. I'm going to try to go quickly because I know I can be boring. All right, the mole. The mole is a number. This is quick review, just like the dozen. The mole means you have this many. Good Lord. The mole means you have this many particles of a substance, okay? For example, if you had that many atoms of helium, then you would have a mole of helium, okay? The mole means the weight from the chart. So helium's number 2, it has a weight of 4. So if we had this many atoms of helium, it would weigh 4 grams. And if we put that helium into a balloon, yep, it would fill that balloon up to 22.4 liters of space. So the mole means a number, it means a mass, and it means volume. Exactly like the people at Dunkin' Donuts. The mole can mean the price. It can mean 1 box of donuts. It can mean 12 donuts. It can mean all these different things. All right, that was the quick review. One other thing. Let's say we had a mole of propane molecules, C3H8. Waiting on the board. Don't know why we're waiting on this board. My computer is being super slow. All right, that's propane right there. Now, this is a common sense thing that sometimes escapes kids. If we have a mole of propane, that means that we have 6.02 times 10 to the 23rd of these entire molecules, which means we would have 3 moles of carbon atoms and 8 moles of hydrogen atoms. So let's draw this propane molecule down here. And we're following the rules. This is exactly what it would look like. C3H8, okay? So if you have a mole of propane, then boom. And someone said, hey, how many atoms of carbon are in a mole of propane? You would say 3 times 6.02 times 10 to the 23rd, and that would obviously give you 1.8 times 10 to the 24th, duh. All right? So that's how many atoms of carbon are in 1 mole of propane. I hope that makes sense. It's no different than saying, hey, I've got a bicycle. Okay? There, isn't that a cool looking bike? All right, stop making fun of me. Now, if you have a bicycle, if you had a dozen bicycles, then that means you have 24 tires, but only 12 handlebars, right? So you'd have 2 dozen wheels and 1 dozen handlebars if you had a dozen total bikes, right? All right, so now done with that quick review. Here we go. I'm going to give you some problems, and you're going to work them. Then I'm going to show you the answers. Okay, here we go. Here we go. Number 1. We're going to talk about oxygen. Okay, and you have 13 grams of O2. All right. If you have 13 grams of O2, question number 1 is, how many moles of oxygen do you have? Okay, and then I'll pause the video here and you'll have to answer it. Okay, now here's the answer. Ready? oxygen, O2, would have a weight of 32 grams per mole. So 13 divided by 32 means you have 0.41 moles. All right? Good job. Number two. Number two. You have 1.1 times 10 to the 23rd atoms of lithium. What mass would this have? How much would that weigh on your scale? How many grams? How many grams would that be? This is a two-step problem. I'm going to go ahead and tell you, you have to convert atoms to moles and then convert the number of moles to mass. Go. Here's the answer. And here's how you do it. You'd say I have 1.1 times 10 to the 23rd. That's the number I'm given. Times 1 over the proper number. The proper number for a mole of atoms is 6.02 times 10 to the 23rd. Times the number I'm looking for over 1. So we're looking for a mass. Lithium weighs 7 grams or 6.941, right? So that's how we would solve the problem. So we would say 1.1 times 10 to the 23rd divided by 6.02 times 10 to the 23rd times 7 equals 1.28. No. 0.128. I'm having a hard time. Oh, no, sorry. 1.28 grams. All right, let's move on. Number 3. Number 3. Well, the board's thinking about something again. Number 3. You have a balloon. And the balloon is filled to a volume of 75 liters. How many moles of fluorine gas are in the balloon? Okay. Now, I'm going to let you answer that. Here's the answer. And here's how you get it. Answer. 75 liters, that's what you're given, times 1 over the proper number for what you're given, is going to give you a certain, no, that's it. That's how many moles you have. Let's see. 75 divided by 22.4. You have 3.35 moles. All right. Let's make it harder. Number 4. Same problem. Just going to make it a little more difficult. You have a balloon with 17 liters of propane gas in it. Okay? That is a balloon that could explode. Haha, yes. All right, so 17 liters of propane gas. All right? What is the mass of the balloon? In other words, how many grams of propane are in the balloon if it's 17 liters? Go. All right, here's how we solve it. 17 liters is what you're given, times 1 over the proper number for what you're given, so 22.4 liters, times, now we're looking for the mass. 1 mole of propane weighs 44 grams. So times 44 grams over 1. That'll tell you how many grams of propane are in there. So 17 divided by 22.4 times 44 equals 33.4. You would have 33.4 grams of propane in there. All right, let's keep rolling. Number 5. 300 grams of hydrogen gas would fill a balloon to blank liters. All right, you answer it. Now I'm going to solve it. Here we go. 300, we're given a number in grams, times 1 over the proper number in grams. Hydrogen gas weighs 2 grams. Times, we're looking for liters, the proper number for liters. Sorry, that's the board, not me, people. We're looking for, that is hilarious, not gonna erase that, times 22.4 liters, because that's the proper number for what we're looking for, equals. All right, you answer that. Now I'm going to answer it. 300 divided by 2 times 22.4 equals. I got 3,360 liters. That sounds about right. 3,360 liters. That's how we do it. All right, let's keep rolling. Number 6. Number 6. A balloon with a volume of 39 liters is full of carbon dioxide. What is the mass of the carbon dioxide? All right, you answer that. Now I'll answer it. 39 liters is the number we're given, times 1 over the proper number. Liters, what's the proper number in liters? 22.4 liters, you're right. Times the proper number over 1, times what we're given here. Let's see, we're looking for grams. The proper number for CO2 in grams is, this is 12 plus 32, is 44 grams. Carbon dioxide and propane have the same molar mass. So we have 39 divided by 22.4 times 44. 76.6 grams is how much it would weigh. All right, let's keep rolling. That would be its mass. And number 7. Number 7. All right. 3 grams of, let's stick with propane, C3H8, would mean there were blank molecules of propane on the scale. So if you had 3 grams of propane, that would mean there were blank number of molecules on the scale if you're weighing it. It's going to be a very big number, right? It's done exactly the same way. Give me your answer. Here I go. 3 grams. Now the next thing we're going to do, times 1 over the proper number. I should sound like a broken record at this point. C3H8 is 44 grams. times. Now we're looking for the number of molecules. What is the proper number for the number of molecules? You're right, 6.02 times 10 to the 23rd. Notice I'm doing the same thing every time. We have this pattern that goes like this in a V shape. The number you're given divided by the proper number in those same units times what you're looking for. Okay? Boom, boom. We're doing this every time. All right? Let's figure out what the answer is. 3 divided by 44 times 6.02 EE23 equals. I got 4.1 times 10 to the 22nd. 4.1 times 10 to the 22nd molecules. Excellent. Number 8. Number 8. 1.7 times 10 to the 23rd, I apologize, times 10 to the 23rd molecules, waiting on the board, waiting on the board, molecules of natural gas or methane have a mass of blank grams. Okay, ready? You solve it, I'm going to solve it. Here we go. Here's the proper number. There's the number we're given, times 1 over the proper number in those same units, 6.02 times 10 to the 23rd, times, what are we looking for? Mass in grams. CH4 weighs 16, so 16 grams over 1 equals, here we go. I got that we would have somewhere around 4.5 grams. 4.5 grams. I hope you're getting this right. Here we go. Let's keep rolling. Number 9. Number 9. A balloon filled to 80 liters contains blank molecules of hydrogen gas. Okay? So if you have 80 liters, how many molecules? Remember, we're looking at a very, very large number. Okay, let's answer it. Same thing, 80 liters is what we're given, times 1 over the proper number. The proper number for liters is 22.4 liters. Times, we're looking for molecules. What's the proper number for molecules per mole? 6.02 times 10 to the 23rd over 1. Here we go, let's solve it. 80 divided by 22.4 times 6.02 EE23 equals, I get 2.15 times 10 to the 24th. That's right, 2.15 times 10 to the 24th. And that leads us to our last problem, number 10. 300 grams of nitrogen gas fill a balloon to blank liters. 300 grams of nitrogen gas fill a balloon to blank liters. How many liters? What volume are we looking for? All right, you answer it. And now here's my answer. The answer, 300 grams over 1 times 1 over the proper number in grams. Nitrogen, 28 grams, times We're looking for liters here. 22.4 is the proper number for liters, and that'll give us an answer. 300 divided by 28 times 22.4 equals, gives me 240 even. 240 liters. Great job for working all the way through the video. Alright, hopefully this new program works out. Peace out from the dirt bike shed.